Hello students, I am Kausalya. Today we are going to solve example 1.10 in chapter 1 in control systems. The problem is write the differential equations governing the mechanical system shown in figure. Draw the force, voltage and force current electrical analogous circuits and verify by writing mesh and node equations. So, the first step is they had asked us to find the differential equations. So this is the given problem and this problem consists of three masses, right? M1, M2 and M3. So the first step is we have to draw the free body diagram of mass M1. So as usual, just count the number of elements which are connected with mass M1. So here we are having 1, 2, 3 and 4, right? Totally 4 elements are connected with mass M1. There is no direct applied force over here, right? So there is no applied force. So the opposing forces are totally 5 in number. That is opposing force produced by B2, B3, K1, B1, and apart from that this mass M1 will also produce some opposing force, right? So first step is write down the list of forces here. So the first force is Fm1, Fk1, Fb1, Fb2 and Fb3. Right. So in the problem there is no displacement is given. So we are considering the displacement of M1 be x1, M2 be x2 and M3 be x3. So the respective displacement of M1 is x1 and their velocity will be v1, right? So again by Newton's second law, we have to write applied force is equal to your opposing force. So here in this case, the applied force is equal to opposing force. So here the applied force is 0, so which is equal to opposing forces Fm1, Fk1, Fb1, Fb2 plus Fb3, right? So just substitute the respective values here. So as we all know, Fm1 is nothing but m1 into d square x1 by dt square plus k1 is nothing but k1 into x1 plus b1 is nothing but b1 into dx1 by dt plus as usual here B2 is connected between M1 and M2. So here we are drawing free body diagram of mass M1. So we have to consider the displacement of M1 first. That is we have to write it as x1 minus x2. So Fb2 is nothing but B2 into d by dt of x1 minus x2. And finally B3. So for B3 we have to write it as B3 into d by dt of x1 minus of x3, right? So this is our equation. The next one is we have to rewrite this equation in terms of velocities. So as we all know regarding velocity, x should be written as x is equal to integral of v into dt and again dx by dt should be written as v and d square x by dt square should be written as dv by dt, right? This is a general rule. So when we replace displacement in terms of velocity, we will be having that is 0 equal to m1 into d square x1 by dt square is nothing but dv1 by dt. So m1 into dv1 by dt plus again k1 into integral of x1 should be replaced by velocity. So here v1 into dt plus b1 into again dx1 by dt is nothing but v. So b1 v1 plus b2 into v1 minus v2 and finally plus b3 into v1 minus v3, right? Let this be your equation number A and let this equation be equation number 1, right? This is your first differential equation of mass M1. The next step is we are going to draw the free body diagram of M2 here.